All right, this is with chapter 6. It is a mixture of systems of equations word problems. So there's a packet of about 50 problems. I'm going to do a few of each type, or maybe one of each type, and then you'll do some over the next few days. We'll start off with one of the word problems, and this one does solving the system, but with graphing. And you know how much I feel about how I feel about graphing and solving systems, but I think they'll make it so that it's pretty cut and dry. You can pretty much tell what the answer is. So let's start off. Kayla sells athletic shoes part-time at a department store. She can earn either $500 per month plus 4% commission on her total sales, or $400 a month plus 5% commission on her sales. Something tells me we've had this problem before. Does that sound very familiar? Or similar to it, only it was a word problem. It really wasn't a graphing. But we'll put it here on the graphing and see how this goes. When you're doing problems like this, you kind of have to go with what your graph, or make sure that you have the graph conducive to the problem, is the way I guess I'll say that. We'll start off with writing the system of equations. So these problems are really good about step by step. I mean, it'll make you go step by step. So write a system of equation to represent the situation. So she has the first job. She can earn $500 plus 4% commission. Okay, so the first job, or her, I shouldn't say job, it's her pay. So I'm going to say pay 1 would be y equals, how do we write 4%, Jared? 0.04 x plus 500. Okay, and then she has the alternative pay. She can get $400 a month and 5% commission. So 5% would be written like 0.05, but definitely starts with a lower amount of money. Okay, so that's how you would start off with the system. They definitely get a set amount of money plus a percentage based upon their sales. Okay, so Y would represent her salary, where X would represent her sales. And now I need to graph that. Well, sadly, I'm going to have to get rid of those two equations and scroll down a little bit. So hopefully you got those. We're going to scroll down here like this. And when I do this, let me kind of repeat that. The first one, y equals 0.04 x plus 500. Well, the way that you would graph that, what would the y-intercept be? Ethan?
Well, 500.
So definitely starts at 500. Okay. And notice across the bottom, the sales are in thousands of dollars. Okay, so I would definitely go by that. I wouldn't try to figure out, oh my gosh, I'm going to rise 0.04 over 1. That would not work at all. You would put $1,000 in there, and if I put $1,000 in there, what would that amount be? Anybody know? Jared? $40 plus the 500, so $540. So let's go with maybe $5,000. If I put $5,000 in there for X, what would Y be? 700. So 5,000 would go up to 700. That might help us out a little bit more. So what would be the next best one to put in, do you think? Octavia?
10,000.
Yeah, I would definitely go with 10,000. So if I put $10,000 in sales, where would that take me? To what? It'd be what? 10,000 in sales wouldn't be, no, not that high. How much? 900. 10,000 in sales would go up to 900. Okay, so that would be enough maybe to get us a nice straight line. So let's try it. or as best we can. Whoops. Okay, we're going to go with that. And then the second equation was y equals 0.05x plus 400. So the y-intercept on this one is 400, so it starts a little bit lower. I'll put it in green if I can. And again, I would put in numbers across for sales that would turn out to be whole numbers. So if I put 1,000 in there, that would give me 50, but it'd be just 450. What if I wanted it to go to an even amount? What would be the best one, maybe, Jared? 2,000 would make it go to what? 2,000 would make it go to 500. Okay, what would be another good one then? What would be another good one, Octavia? 4,000 would be how much? 600. Okay, so I'm kind of seeing a pattern. What would 6,000 do then? 700. I'm going to keep going like this, and this might help me make a straighter line. What about 8,000? 800. What about 10,000? 10,000 would be 900. I think we found our intersection point, so that's good. I think if I didn't have such a thick point that it would be a little clearer. So it says, what is the break-even point? This would be the total amount of sales that Kayla would have to sell to earn the same income for the month from both situations. So what's the break-even point, Octavia?
10,000.
The break-even point would be $10,000 in sales. And what would her salary be? 10,000 in sales, Jared? $900 in her money. Okay, so the break-even point is 10,000 in sales, and she earns $900. So, leading up to the break-even point, which method was the best? The first one or the second one? Leading up to the break-even point, which one brought her the most money, Josh?
The first option.
The first option, where she got $500. But then after the break-even point, it switches around, right? So if she's going to make more than $10,000 in sales, she definitely wants to choose option B, because then after the break-even point, it goes higher. So that's where people have to understand about themselves, what they think they're going to be able to do, whether you want to go more based on a percentage or more based on the given amount. The question D that's down there that I can't pull up because I'll lose everything, it says, if Kayla sells $20,000 in shoes, which would be the best offer? And I think we kind of already answered that. Megan, what should we say? Right. So for answer D, you would say the second choice of $400 plus the 5% commission would be better if she could sell more, if she sold the 20,000. So that's what you're going to do with the ones where you're graphing. You come up with your two equations and then kind of go from there. Okay, so they're going to ask about the break-even point, what that really means maybe, and what would be best for different situations. Okay, questions about that? So I'm going to leave some of those there for you then. Let's skip ahead to problem number 5. So there'll be some that you'll be able to do on your own then. We're going to skip ahead to problem number 5. Mary ordered lunch for herself and several coworkers on Monday and Friday. On Monday, she paid $7 for 5 sandwiches and 4 sodas. On Friday, she paid $6 for 4 of each. our first problem is to write an equation for Monday and Friday. Well, we're going to have to do this first. I'm going to let X represent, I'm going to pick something different there. Hold on, different color. I'm going to let X represent sandwiches. And I'm going to let Y represent sodas. Okay, and that's, I just picked that at random. You can do whatever. You wouldn't want to use like S because they're both S's. So on some of them you might want to put the letter that represents what it is, but these I wouldn't. Okay, so Monday, $7 for 5 sandwiches and 4 sodas. What do you think that equation would look like, Maitri? 5x plus 4y equals 7, definitely. Okay, Friday, she paid $6 for 4 of each. What's that Friday equation going to look like? 4x plus 4y equals 6. So we have written our system. Now we're going to solve the system and find the cost of the soda. So it doesn't tell us which way to go about doing this. I definitely wouldn't use substitution, right? I think what I would probably do is take this one times a -1. You okay with that? And I would have 5x plus 4y equals 7. -4x minus 4y equals -6. Make sure you take that negative all the way through. And now add these. So I've got 5x and -4x, so that's just a 1x. The 4y's cross out, and 7 minus 6, so we have 1. What does that mean in this problem, Tor? Sandwiches are $1. That's what that means. Okay, that would mean sandwiches are $1, which we don't need to know that. It wants to know the cost of the soda. So I would definitely do this then. I would do a substitution here where I'd say 4 times 1 plus 4y equals 6, and you could plug it into any of the equations. So 4 plus 4y equals 6, subtract 4. And, whoops, I shouldn't have crossed that out. 4y equals 2, and then divide by 4. So how much is a soda? Yeah, it would come out to 0.5, which would be 50 cents. So your answer would be 50 cents for a soda. Questions about that? Yep, question.
Could you skip all the elimination by just like noticing that the answers of the 7 and 6 are $1, like 1 point apart, and then 5 and 4 are 1 point apart?
Yes, in fact, part of the elimination lesson was you could just start right here with these two and not do this, and do a subtraction. And I kind of steered clear of that because I know through the years that I've taught that way, if there's any negatives in that bottom equation, kids mess it up for some reason because negatives mess things up. But that is an option, that you just can subtract the equations and not just add them. I just like to do it that way because it seems like there's less errors. But you could definitely do it that way. Definitely you could do it that way. Okay, let me